collect 5 mils of bundles over 5 mils of water. Not very much.
They're creating a bank of genetic material for artificial insemination in the future.
What I'm after is mostly the sperm that's located in these bundles. Then we freeze it in liquid nitrogen. And from there, it can be frozen and thawed when the sperm is still alive. And it can be used in fertilizations the same night, a year, 10 years, 100 years, whatever you need later. So what this is basically banking down some of the genetic diversity in case we continue to lose corals everywhere.
For Madeline, having a sperm bank of diverse corals on hand will make it easier to craft hybrid species, using cryopreserved sperm when other coral species spawn.
So you're focusing on the sperm, not the eggs?
Yeah, so far we cannot successfully freeze the eggs, so they're no longer alive after the freezing process, but the sperm is very successful.
No one has yet mastered freezing coral eggs. But cryopreserving something else has exciting promise.
We've also started to freeze the algal symbionts of corals.
Madeline has successfully grown heat-tolerant algae, the coral symbiont, in the lab. Tonight, Madeline and her team are testing a radical idea. She'll freeze the heat-tolerant algae, then thaw it and introduce it to coral. The question is, will coral larvae accept it?
How has it been going?
It's good, just about ready to cryopreserve now.
Liquid nitrogen flash freezes the algal cells, the symbiodinium.
We're trying to freeze them really, really rapidly so that the liquid that they're in basically just sets like a solid piece of glass.
The frozen algae is immediately thawed and introduced to dozens of coral larvae in a single drop of water. If they're accepted, it opens new possibilities for helping bleached corals on the reef.
How long do you think it will take for the larvae to take them off?
We're going to assess them after 2 days and then again after 4, so it'll give them a little bit of time to take up this cryopreserved symbiodinium.
Then Madeline checks on other corals for signs of spawning.
Yeah, the other species is going to spawn too. It's setting. We've got lots of colonies isolated, so I think we're going to have hybrids tonight. It's very exciting.
In the lab, it's time to attempt a hybrid coral species.
So when we do this hybrid process, we do not actually know beforehand whether the offspring will be more resilient. That by chance you may end up with some traits, some characteristics that might be beneficial under climate change.
Millions of coral larvae are kept in constant circulation. In a few days, they'll be released into the climate-controlled tanks. But now, the team checks on the progress of the larvae exposed to heat-tolerant algae that's been frozen, then thawed.
So I think that they're infected. Ah, they're infected. That's really fantastic. That means we can now look at how that affects the temperature tolerance.
Under a microscope, it's clear the frozen, then thawed algae, the symbionts, have been absorbed by the coral larvae.
That's a big success because I guess one of our best hopes for building heat tolerance is through the symbionts.
I think, yes, making the symbionts more tolerant is probably the way to go. We can think about spraying the reef with symbionts, perhaps.
So because they're so small and so quick to culture, the idea of scaling up to a whole reef full of heat-tolerant symbionts is actually far more practical than planting baby corals.
That's right, yeah.
If large amounts of heat-tolerant algae can be cryopreserved and stored, they could be a first aid for bleached, starving reefs.